Have you ever thought about what would happen if the sun, the thing that lights you, warms you, and literally feeds you, just vanished? I have actually. This whole thing hit me last winter, here in New York, when my apartment heater broke for 3 days straight. I was wrapped in a blanket, teeth chattering, and at some point I thought, this is basically a tiny, kind of pathetic preview of what a sunless world would feel like. So what if it wasn't 3 days? What if it just never came back on? That's what we're getting into today. Okay, real quick, the sun isn't going to just poof out of existence. That's not how physics works. But it's a fun thing to imagine, and honestly, imagining the impossible is how you end up understanding the possible. Einstein used to do this constantly, picturing himself riding alongside a beam of light and seeing what broke in his head. We're doing something similar today, just with more freezing to death involved. So, right now, if you look up, you see the sun. Except, and this messes with me every time I think about it, what you're seeing is the sun as it was 8 minutes ago. Light takes 8 minutes and 17 seconds to get from there to here, which means if the sun disappeared this exact second, you wouldn't know. For 8 more minutes, you'd be standing there with a perfectly normal, glowing sun overhead, birds singing, you drinking your coffee, completely unaware. And then, 8 minutes and 17 seconds later, it just goes out, like someone flipped a switch you didn't know existed. But honestly, the light isn't even the scary part. Gravity is. With my heater situation, worst thing that happened was I was cold for 3 days. But gravity disappearing means the Earth actually flies off its orbit. Here's why. General relativity says gravitational information also moves at the speed of light. So the second the sun's mass is gone, Earth doesn't feel it instantly either. It takes those same 8 minutes. And then the invisible thread that's been holding us in this loop around the sun just snaps. We stop curving and go shooting off in a straight line into deep space. Something like 67,000 miles an hour. I think about it like a rock tied to a string, the kind you'd swing around as a kid. The string snaps. The rock doesn't keep circling. It just flies off straight. That's us. We're the rock in this scenario, which is a weird thing to sit with. Here's the part that actually surprises me most though. The cold takes a lot longer to show up than people assume. Earth kind of acts like a thermos. All that atmosphere, all that ocean, it's storing a ridiculous amount of heat. First week, average temps drop below freezing, sure, but it's not instant hellscape mode. A month in, we're around 0 degrees Fahrenheit, so permanent polar night basically. A year in, -100 or so. Colder than Antarctica on its worst night, and Antarctica's worst night is already brutal. Little story here. I was at a conference in Boston last summer, met a climate scientist, I won't say her name, and she said something I haven't been able to shake since. She said, people think the planet's the fragile one. It's not. We are. And that's kind of exactly what this scenario shows you. The planet cools down slow, almost calmly, on its own schedule. We're the ones who fall apart way before that. Oceans are a weird case too. They don't freeze right away. Surface ice is over in a few months, but that ice layer basically acts as insulation, kind of like how a frozen lake protects the water underneath it. Scientists think the deep ocean could stay liquid for maybe 1,000 years. So somewhere down there, near a hydrothermal vent, there's some extremophile bacteria just going about its business, completely oblivious that the entire solar system fell apart above it. So what would we actually do? First 24 hours, probably chaos, not going to sugarcoat that. But after that, and this surprised me when I first read about it, humanity's odds aren't zero. Nuclear plants keep running fine. They don't need the sun. Geothermal energy is still there, still coming from the Earth's own core. Some scientists think, with the right organization, underground cities, controlled agriculture, a small chunk of humanity could actually pull through. Not in a cool The Martian kind of way though. More like a grim, exhausting, everybody's fighting over heat kind of way. Another one for you. Last year I was watching the sunset in Central Park, and there was a kid next to me who asked his dad, "Does the sun rise every single day?" And the dad just said, "Of course, it's been rising for millions of years." I remember smiling a little to myself because, well, technically the sun's got about 5 billion years left, so the dad wasn't wrong. But that kid's question is actually kind of ancient. The Egyptians believed their sun god Ra traveled through the underworld every night and had to fight his way back to rise again in the morning. This fear, what if it just doesn't come back one day, has apparently been rattling around in human brains for thousands of years. Plants stop photosynthesizing without light, obviously, and that's the bottom of the food chain, God. They start dying within weeks. Herbivores starve, then carnivores. This actually already happened once, sort of. After the asteroid that killed the dinosaurs, dust blocked the sun for months, and the whole food chain collapsed the same way. So this isn't really science fiction. It's just a more extreme rerun of something that's already happened on this planet. My favorite part of all this, honestly, is the sky. No sun means no daytime, obviously, but it wouldn't be pitch black either, because the stars are still up there even without moonlight bouncing around. For astronomers, this would almost be a dream. Light pollution just disappears, and you'd get the Milky Way every single night in perfect clarity, right before freezing, unfortunately. And something I keep wondering about, the moon. It stays put, gravitationally, because it's tied to Earth, not the sun. But nothing lights it up anymore. Since the moon doesn't make its own light, it just bounces the sun's back at us. So that whole silvery moon in the sky thing, gone, right along with the sun that made it possible in the first place. I don't know. I think about why I even find this stuff worth thinking about, and I think it's because it makes something obvious feel new again. Every second of our lives is basically riding on the generosity of a star that's 93 million miles away and doesn't even know we exist. I don't think about that while I'm drinking my coffee in the morning. You probably don't either. Maybe we should a little. I spend most of my actual working days buried in data, in a lab, doing pretty unglamorous stuff. But sometimes, on the subway of all places, it hits me. There's a giant nuclear furnace burning somewhere above my head right now, handing me an entire day of life for free, and I'm not even thinking about it. Kind of terrifying, kind of beautiful, honestly both at once. Anyway, the sun's not going anywhere for a very long time. 5 billion more years of this, give or take, before it swells up into a red giant and possibly swallows the Earth whole. But that's so far in the future it barely feels real to think about. Everything we just went through was a thought experiment, sure, but it's also kind of a reminder of how fragile, and somehow also how insanely well balanced, this whole thing actually is. If this made you look at the sky a little differently, subscribe. We do this kind of what if stuff on deep space and beyond pretty much every week. And drop a comment. How long do you think humanity would actually last without the sun? I'll be reading through the answers. See you in the next one. And, maybe say thanks to that star above your head at some point today.